Hello. In this session, we are going to learn the basics of electronics. We should understand that without electronics, no digital board or equipment can be built. And this session is going to serve as a very fundamental learning for anyone who wishes to use any boards in terms of building products. After the session, the listener will have clear understanding about the breadboard connections, the types of jumper wires and their usage, the electronic components and their usage clearly. Prerequisites for hardware interfacing is what we are going to learn right now. What is a breadboard? Breadboard is a plug and play prototyping board, unlike the traditional PCB boards where one needs to solder the electronic components. It has got two types of connections on it. One is parallel connection, another one is serial connection. You can see that the same has been highlighted here. This is called serial connection. You can see it, and these two representations shows the parallel connections. Jumper wires and single stand wires. We have sufficient space to place our components on the breadboard. But how are we going to connect the components? Normal multi-stand wires cannot be used or inserted in the breadboard. It is complex. So for making the connections on the breadboard in a much easier way, jumper wires or single stand wires can be used. Jumper wires and single stand wires are very friendly with the breadboard and they can easily fit into the pins of Arduino or any microcontroller of your choice. We have presented the pictorial representations of single stand wires and jumper wire for your reference. Types of jumper wires. There are three different types of jumper wires for different types of connections. Male to male jumper wires, male to female jumper wires, female to female jumper wires. The male to male jumper wires will look like this. Both the ends have the sharp pins. Male to female will have one end with a sharp pin and another end with a blunt one. Female to female, both the ends will enable you to connect it to a pin, and that's why we refer it as female to female connection. Male to male jumper wires have single strand coming out on both sides technically. Male to female jumper wires have single strand on one side and hole on the other side. Female to female jumper wires have holes on both the sides. This difference is to be understood very clearly for you to choose the appropriate jumper wires in your product. Basics of electronics is very important, and here we are going to learn the fundamental components in electronics. In IoT, hardware part of the system plays very important role. The electronic circuit that is designed should be consuming low power, it should be efficient, as well as it should be stable. While we meet all these requirements, it should also get you the expected output. So we need to learn the fundamentals. Some of the basic and mostly used electronic components are discussed in this session, and the first one in the queue is resistors. The resistors, as you know, resist the flow of the current, which means that they can protect the components from higher voltages getting across them. They do not have any polarity, which means that no plus or minus. You can see a resistor which is presented in front of you pictorially. The next one in the queue is capacitor. These capacitors can store the current flowing through them in the form of electrical energy. It stores. These possess polarity and must be connected accordingly, which means you need to know which is positive and which is negative. Capacitors are presented in front of you as well, but there are multiple types of capacitors available, so you got to be cautious about selecting appropriate types of capacitor. There are some more basic electronic components that we must learn. The first one in that is inductor. Analogous to the capacitor, inductors store the energy in the form of magnetic energy when the electrical current is passed through them. And some inductors are presented in front of you, and multiple types are available here as well. You need to be cautious about selecting which one suits you better. Next one is diode. Diodes have the property of rejecting reverse currents and allowing the current only in the forward configuration. Hence, it can be used to prevent components getting spoiled by short circuiting. You can close your eyes and say that any circuit will have some diode at least in its entirety. The next one to be understood is the resistor color coding. We are taught this way during our early days of engineering. B.B. Roy, Great Britain, very good wife. B stands for black, next B stands for brown, R stands for red, O stands for orange, Y for yellow, G for green, B for blue, V for violet, G for grey, and W for white. And finally, we have got gold and silver, and they are called tolerance bands. You need to remember this color coding. There is no other option. And we have shown you some representation here how to calculate the value of a particular resistor. There are three bands available: first band, second band, and third band for the resistor that we have taken, and each of them have got the value in front of you. The first band, second band, third band, along with the multiplier factor, will get you the value of the resistor that you are verifying. It's very simple. You should not forget the multiplier. You should not forget the tolerance band values, and that is it. It is easy for you to calculate the value of the resistor. And you should start counting in the opposite direction from the tolerance band. Here, the tolerance band is light gold in color. So opposite to it, the first band should be green, the second band should be blue, the third band should be yellow. It's very simple, and that's how we got to learn it. And that is it. This helps you in understanding the color coding. We prompt you to test it out by taking multiple resistors and to calculate the values as accordingly as you have to. Thank you. After going through the session, you can understand how to install the Fritzing software, how do we design a circuit with Fritzing, and finally, how to download a new component into Fritzing. All these will help you in using the Fritzing seamlessly. Let's first understand what is Fritzing. First, we got to install it. For the installation to be complete, you need to download the installables first. The installables are available at http://fritzing.org/download. You need to download the apt version of Fritzing software based on your operating system. I have Windows 10, so I have chosen Windows operating system, and I need to also download the appropriate version as 32-bit or 64-bit as per my requirement. The support has been presented also for Mac OS X, Linux variations as well. Just click that, you will get it downloaded. Once it is downloaded, you can observe that it is downloaded as a zip file. Zip file cannot be used right away, so you need to unzip it, which means you got to extract it. Extract the zip. Once it is done, you can find that fritzing.exe file will be available there. Just double click it and we can run it. Now, we are going to learn about the options available in the Fritzing. Designing a circuit is very important, but you need to implement it in real time. For you to implement it in real time, design will help you. This Fritzing provides you clear options for designing your circuit in a much easier way as well as efficient way. It gives you breadboard option, schematic option, and PCB option. Breadboard is for testing, schematic is for easier understanding, PCB for rapid prototyping. Also, we have an appreciable feature called as code, which can be used for coding all the Arduino related coding which you can do in Arduino IDE here itself, which means you have got the complete facility available with Fritzing. It starts with design, it ends with coding. All these are available at one go. Now, the options available in Fritzing are to be analyzed. You need to understand how do we use the available options, how do we use the parts available in Fritzing first. After opening the software, on the left side, we have a parts pane. We call it pane. And when you go there, you can find all the components, fundamental electronic components, IoT related components, everything will be available there. They will all be listed along with a clear diagram for you to understand what that component is. Now, at the bottom of the parts pane, we have an inspector pane as well. What do you mean by that inspector pane? When you click on a particular component, this inspector pane will give you a complete detail about which component are you using, what all the properties of it, Do we have any tags available for it? What is it all about can be clearly understood by that inspector pane. When you click the upper side of the pane, you get the component. When you click the lower side, you can understand the details of the component. The inspector pane provides you the complete brief note about the component. Now, the breadboard. What is a breadboard? A breadboard is the easiest option for anyone to test what they want to build at the later stage as a prototype. Fundamental electronics is all taught with breadboard. And here in Fritzing, we have the support for breadboard. Now, in the parts pane, you got to search for Arduino Uno. Drag and drop the Arduino Uno to the workspace which is at the left of the parts pane. Next, search for LED. What are we going to do? It is obvious. We are going to interface LED with Arduino board as you are going to see right now. Now drag and drop the appropriate LED and the required resistor to the workspace. We use resistor here to regulate the voltage which is going to flow to the LED. We are going to go with the next level which will complete the connections in this circuitry. It is a very simple circuitry, yet I request you to pay the attention. Insert the LED resistor on the breadboard. This is all virtual and you need to just drop it there with your proper movement of the mouse or in the mouse pad in the laptop. Connect one end of the resistor to the positive terminal of LED. Connect the negative pin of LED to the ground pin of the Arduino Uno. Another end should go to the digital pin 9 of Arduino Uno. You can choose any other digital pin, but we have chosen it and accordingly we have coded it also in the software. It can be any options available in front of you. And color of the wire can also be changed, which can help you out in differentiating which wire is meant for positive, which wire is meant for ground. All these are beautiful options which are phenomenally supported in Fritzing. Now you can change the color from black to white. Any color can be chosen and that should be properly done as well. You can in fact follow a guideline for your circuit that you are building and that should be consistent. Now please note that in this video series, we have followed a clear guideline. All the black wires in the design represent ground connections, while the red wires represent VCC connections, which is power supply. Likewise, you can follow a consistent approach to represent which is ground, which is VCC, etc. in your design. That's always appreciable in any design. Now, what is schematic? Well, we have connected it. We have shown you in the previous slide how to drag and drop the LED, how to connect the wire, how to connect the resistors. All these things have been clearly taught. But that is the representation with the physical component. But how does it look as a schematic? The schematic is presented in front of you, which will also be available as an option, which will certainly enhance the understanding clearly. This is more of electronics way of presenting it. The previous one was more of computer science way of understanding it. For a computer science graduate, the previous setup will be helpful. For an electronics graduate who wants to go with complete understanding of how the electronic circuit looks like, what are all the pin details, how exactly things will work when you have a physical board with you, this schematic will help you. Now PCB, it is a step higher. If the circuit is tested and it is free from errors, the next thing is to make it real. How do you make it real? We need to get the PCB ready. This will give you greater accuracy and most importantly, breadboard cannot be sold in the market. Only the printed circuit boards enabled stuff can be sold in the market as a product. This will miniaturize the circuit space. This will make sure that every connection is proper. This is the way you need to finally get your product out. Before printing on a PCB board, the circuit can be designed using PCB option in Fritzing. Once your PCB option is used for designing the PCB, you can give it later on to the PCB maker and they will get you the printed circuit board ready for you with all the details that you have given them clearly. The next very important part of discussion is downloading a new component. Most of the times we may not have all the components available with us for usage. For example, in this case, I am searching for pulse sensor, which you can see in front of you is not available, which means we got to download that or enable the usage of pulse sensor from this setup through some additional steps to be done. For example, I'm going to explain you the steps and the sequence that are required to include pulse sensor as one of the components which can be used later after this process is done. How do we do it? Very simple. To include a new component, you got to meticulously follow the steps. First, go to Google. Type with the component name Fritzing, which means pulse sensor Fritzing is the thing that you need to type and search now. Once you type and once you click the search button, you will get GitHub pages listed there. And you need to go to any of those GitHub pages that will help you with the rest of the options. Here we have used world famous electronics slash fritzing underscore pulsar sensor underscore files. What do you mean by that and what do we do here? Very simple. I am going to include the files that will represent this pulse sensor, and after this inclusion, after the process that we are following, the pulse sensor will be made available for you to use. For that, we got to do some steps. That is what is being done here right now. Once it is searched and once you have selected the GitHub link, you are 50% done. Now, download the fritzing file. Here, pulse sensor, we need to copy it into the initial extracted frisking folder. What do you mean by that? Very simple. We have downloaded the frisking folder during the first step, which should be available at some specific folder in your system. It could be in documents, it could be downloads. Make sure that you know where it is available. Now here you got to download your pulsensor.fzpz into the same initial extracted frisking folder. Only then it can identify. It is very simple process. You already have a bunch of components available in a box. You are going to add one more component into that. So you need to keep it inside the box. Now open the new frisking file and search for the pulse sensor. It should be available in front of you. Thank you very much. Hello. Now we are going to learn about how to download the Fritzing software as well as how to proceed with the installation. First, visit the website fritzing.org/download. I repeat, the spelling is important. fritzing. So once you go there, you can see that you've got options for Windows 32-bit edition, Windows 64-bit edition, Mac OS, Linux, and you choose the most appropriate edition for your system. I have got a Windows 64-bit edition, hence I'll have to download the Windows 64-bit edition software. The moment I click it, I start getting the zip file downloaded appropriately into the downloads folder. Now, what is the next step? It is a zip folder, so I need to extract the contents out of this zip for me to use it. Let us extract it right now. So how do we do it? It's very simple. I need to extract it to the folder called documents. We have the documents folder already available in our Windows machine. Just extract it there. I have already done it, so I'm not going to re-extract it. But for you, for the first time, you got to extract it. And you can see that it's all properly getting extracted here, and it may take few seconds for you to completely get it extracted. Once it is done, the process is all simple. I'm going to go to the extracted folder now, and it is easy for us to understand further. Here you have the icon and just click it, and that's all. The fritzing is loaded. It will take maybe few seconds the first minute for it to be loaded completely, and then it's all easy. You now have got the clear cut panel available in front of you for you to use it. As I already told you, we have got breadboard, schematic, PCB, and code option available with you for you to use it. Now we are going to do some sort of demo for you to understand things better. Clicking breadboard will get you the breadboard option immediately available in front of you. Now, in the parts option, I'm searching for Arduino. It lists all the available Arduino support immediately, and you can see it right in the right hand side. Now, once done, I am dragging and dropping one of the Arduino boards, which is nothing but Arduino Uno for the interfacing exercises. Now, I'm going to interface resistor and LED. For LED to work fine without any fluctuations, I need a resistor to be used. So I have the resistor, LED, and Arduino Uno available in front of me. I am just moving it as per my requirement. I need to now get these three interfaced properly. So how do I do it? I need wiring to be done most appropriately, and that's what I do right now.
You can see that the wiring is all done real time and it is all very easy, and the color of the wiring can also be selected as per your wish. You can see that I changed it to black color right now, and you can prefer your own coloring guidelines for you to consistently represent ground and voltage source. Now again, we are going to wire the rest of the components with Arduino clearly. You can see that this is now color change is happening, and I'm changing it to blue color to represent that this is different from the ground. And all these can be done to see how exactly the design looks like. And this is the usage of the breadboard feature that is supported in this Fritzing tool. It's a very simple yet very effective option. Now we are going to go to the schematic where whatever we have drawn in the breadboard is all made available here as a schematic. This would be much more useful for an engineer who has got electronics knowledge very clearly and who wants to upgrade his electronics knowledge to analyze from this schematic. For the people who have got limited knowledge on electronics can still follow the breadboard approach to understand things better. Now, the next one is PCB. How does it look like when we have to generate a PCB? So we will have to get the PCB image generated, and that's what is available here. And if we give this to the PCB makers, they will be readying you the PCB completely available with this layout, and it will be perfect and precise. And the next option is coding. For now, we have clarified how exactly to use the breadboard, the schematic, and PCB. Also, how to use the core parts which are available and by default supported in the Fritzing tool.
Here, we are going to understand how exactly to include a new component as available component in the Fritzing software. Now I am searching for pulse sensor. It is not already available in the existing software, so we need to include it as a new component. For it to be included, we got to follow certain steps, and the sequence is going to be conveyed to you right now. Go to Google and type pulse sensor space Fritzing. Very simple. The first link is what you need right now. Just click that link, you will be taken to the GitHub right away. When you go there, you will have options available for you as you are seeing in front of you right now. In that, you select the clone or download option. Once you click it, you will have download zip option available in front of you. Click that. You will start getting the file downloaded into your download folder, and go there right away. Now extract the content into an appropriate folder. Where do you extract is very important, because you must be having that in a proper folder without any deviation. I have it in the documents folder, so I am going to documents. There I go to Fritzing folder and I extract it there. If you have it in documents, you got to download only it in the documents folder. Now, after you extract it, you need to open that further, double click it so that that particular component's exe gets run so that it can be made available. Once it is run, you can see that that particular component pulse sensor is available for you to use right now. That is it. It is a very simple procedure for you to include any such component in the Fritzing software easily. Thank you.